Okay, so here, I'm just saying kind of briefly what E is. E actually turns out to be a number that's irrational, and it's about 2.71. So we can actually consider the function f of x, which is e raised to the x, and e is between 2 and 3. So of course e is positive and not equal to 1. In fact, e is greater than 1. So its graph would look something like this. Here's 0, the x-axis, here's the y-axis. So basically we have the graph of e to the x, and the vertical intercept as before is 1. We have y equals 0 is the horizontal asymptote, and so on and so forth. So it's really just a special case of the exponential function where the base is greater than 1. All right, so here I'm presenting what exponential equations are. So these are equations that involve, as we see here, they involve a to the x, where a is positive and not equal to 1. So exactly how would we solve these was, as you'll see in the examples, one method we can use is this law of exponents, where if you have two bases are the same, then the exponents have to be the same. So if you have two bases are the same, then the exponents have to be the same. And that's what we're going to use. So let's use the first example. So as you can see here, we have two powers of 2. Namely, we have 2 raised to the 2x minus 1 equal to 2 raised to the 7th. Now, since the bases here are both equal to 2, the exponents have to be the same. In other words, from here, we get 2 times x minus 1 is equal to 7. So now we can solve for x. So from here, let's get x. So we want to isolate it. So we add 1 to both sides. 2x is over here. 7 plus 1 is 8. These cancel. Here we divide by 2. The 2's cancel. We get x equals 4. So for the first example here, we get x is equal to 4. And that's our solution. Now this one's a little bit different because, as you can see, we have 4 raised to something, but on the right side we have 64. So we want 64 to be 4 raised to something. Now what is that something? I don't know. But notice that 64 is 16 times 4. And 16, we know, is 4 times 4. So really what we have here is 4 times 4 times 4, which is 4 cubed. So we have 64 is a power of 4. Namely, 64 is 4 cubed. So what we have then is 4 to the 5x plus 1 is equal to 4 cubed. And since here we have 2 powers of 4 equal to each other, again, that tells us the exponents are the same. So from here, we get 5x plus 1 equals 3. So here, now we can solve for x. Subtracting 1 from each side. These cancel. We get 5 times x. 3 minus 1 is 2. Divide by 5. 5's cancel. We get x is 2 over 5. So we have our function h of x is 2 to the x minus 4. It might be a little hard to see, but I'm asking here, what is h of 6? Well, h of 6, again, by direct calculation, that's 2 to the 6 minus 4. 2 to the 6, though, is 64. So we have 64 minus 4, which is 60. Now, it also says, what is the point on the graph of h? Well, any point on the graph of h is x, comma, h of x. So in this case, we're going to have 6, comma, h of 6. So we just calculated h of 6, so we get 6, comma, 60. Good. For this one, we want to know if h of x is 12, what is x? So we want to basically find x such that 2 to the x minus 4 is 12. Okay, so again, let's get x all alone. So let's get the 4 out of here by adding 4. These cancel. We get 2 to the x is 16. But now the question is, okay, well, is 16 a power of 2? Well, we know that 16 is equal to 4 squared, right? And 4 is 2 squared, so we have 2 squared squared, which is 2 to the 2 times 2, which is 2 to the 4th. So in other words, 16 itself is a power of 2. 16 is 2 to the 4th. So from here, we actually have 2 to the x is 2 to the 4th. But again, that tells us the exponents have to be the same. So because of that, we get x is 4. Good. Okay. So that's what we end up with. Good. Okay. So now for the point on the graph, well, it's just like up here, instead of 6 though, we have 4. So we're going to have 4 comma x to the 4, which is h of 4, which is 12. Now here we want to find x, so h of x is 0 if there is a solution. So we have 2 to the x minus 4. When is that equal to 0? Well, if we add 4 to each side, these cancel. We get 2 to the x is 4. So from here, now 4 we know is a power of 2. We know 4 is 2 squared, so we get x must be 2. And that's our solution.